What are common mistakes in stack trace analysis? Have you ever stared at a stack trace and felt completely lost? You are not alone. Analyzing stack traces can be tricky, and there are several common mistakes that can make debugging even harder. Let's break down these errors so you can debug more effectively. First, many people confuse where the error occurred with where it originated. A stack trace shows the point where an error was detected, but that is not always the root cause. Beginners often focus only on the top line, thinking it caused the problem. The real issue may be several calls deeper in the stack. To debug properly, trace back through the stack to see where the invalid state or input began. Next, ignoring the context of method calls is another common mistake. Stack traces list method calls in order, but without understanding what each method does, it is easy to misinterpret the trace. An error in a utility method might stem from incorrect input passed from a higher-level method. Always examine the arguments and the sequence of calls to pinpoint the source of the problem. Overlooking exceptions from third-party libraries can also lead to confusion. When errors happen inside these libraries, stack traces can become lengthy and filled with unrelated calls. It is easy to get lost in these external calls. Focus on the last method call within your code before the third-party calls begin to isolate the problem. Another mistake is not reading the entire stack trace. Developers sometimes focus only on the first few lines and miss important clues further down. The full stack trace may contain caused by sections or nested exceptions that reveal the underlying issue. Skipping these details can lead to incomplete conclusions. Misinterpreting catch-and-rethrow patterns is also common. Some programs catch exceptions and rethrow them, which can obscure the original stack trace. This may cause confusion about where the error first occurred. Understanding how exception handling affects stack traces is key to tracing the problem correctly. Failing to correlate stack trace lines with source code is another pitfall. Effective debugging requires mapping the stack trace lines to the actual source code files and line numbers. Without checking the corresponding code, it is tough to understand why the error happened. Sometimes the code at the error line looks fine, so look at the calling code or input values. Lastly, neglecting to validate input or state leading to the error is a mistake many make. Errors often result from invalid inputs or unexpected states passed through multiple method calls. Stack traces alone do not show these values, so assuming the error is only in the indicated line can be misleading. Investigate how data is passed and transformed through the call stack. To analyze stack traces effectively, start reading from the bottom to the top. Identify the first method in your own code that appears in the stack trace to localize the problem. Look for exception types and messages to guide what kind of error occurred. Use debugging tools to inspect variable values at different stack frames if possible. When dealing with third-party libraries, focus on your code's interaction points rather than the entire external call chain. Be aware of exception handling patterns that might alter the stack trace appearance. By avoiding these common mistakes and applying a systematic approach, you can master stack trace analysis and fix programming bugs more efficiently.